All right. Well, welcome everyone to 24 Hours Have Passed SQL Server 2014 edition. We're excited you could join us today for Silviano Coriani's Ask Me Anything session on SQL Server in Azure VMs. This 24 Hours Have Passed event consists of 24 consecutive live webcasts. You probably caught on to that by now. This is the 23rd, and the recording of this session will be available in about a week at 24hoursofpass.com. My name is Aaron Nelson, and I am one of the hundreds of BI consultants at Slalom Consulting. I've got a few quick introduction slides before I hand the reins over to Silviano. He'll speak for 40 to 45 minutes, but you can go ahead and start asking your questions right now if you want. You don't have to wait, and we'll look through them and start answering them right away. And we've also got quite a few prepared questions that have already been sent in that Silviano is ready to answer. If you require assistance during the session, use the raise your hand button. If you are having trouble seeing any of the code examples, go ahead and maximize your screen. And most importantly is if you want to send us a question, type your question into the pane on the left, and then we'll go ahead and get that over to Silviano. There will be a short evaluation at the end of the session. Your feedback is very important. Please fill it out. It'll pop up right as we end. Sorry, next slide, Silviano. Oops. Oh, sorry, there was lag. Make sure if I'm on the right one. Can you go back one, Silviano? There we go. Perfect. Now there. I'd like to take a moment to thank our event partner, Microsoft, also one of our global sponsors. The staging of this 24 Hours Have Passed would not be able to be available free of charge without their support. So we want to thank them for that. Next slide, Silviano. And in case you haven't heard, the PASS Summit 2014 is coming up in November. We'd love to have you out there with us. It takes place in Washington, Seattle, Washington, from November 4th to the 7th. It'll feature over 190 sessions with world-class SQL Server experts. There will be developers from Microsoft, as well as MVPs and other experts like myself. Over 5,000 people will attend the PASS Summit, so it's a pretty big event. It's a great place to network and meet face-to-face with your peers. The PASS Summit is the largest event in the world, so you really can't find another larger gathering. You can contact your local chapter for discount code to save $150, and you can get the best savings if you register before this Friday, June 27th. Next slide. Once again, before I go ahead and turn it over to Silviano, I want to go ahead and say you can start asking your questions right away and start putting them into the question pane. And Silviano, with that said, I will turn it over to you and let you start with your introduction and then go into the questions you've already have prepared.
Thanks, Aaron. Good morning or good afternoon or good evening, whatever, depending on where you're based. My name is Silvano Coriani. I'm a program manager in the Azure CAT team, formerly known as SQL CAT. My area of expertise is around storage and data management technologies, both relational and non-relational. I'm working on SQL Server since a long time ago. And just recently, in the last 2-3 years, I'm specifically focused on implementing data-centric solutions on Azure and in hybrid scenarios. So the idea for the session today is to go through some of the questions that typically people is asking us when we are engaging in customer and partner projects all over the world. I prepared a number of questions that basically are summarizing the the typical set of questions that people is interested in when they are planning to move SQL Server workloads on Azure virtual machines. Last year we published this white paper together with some colleagues of mine that, by the way, will be refreshed later this month with some new and up-to-date information. But you can still find a lot of interesting technical details around how to set up and configure SQL Server in Windows Azure virtual machines in the most performing way. We also have a kind of a condensed checklist that we just published on this URL that you can find on the slide. That is kind of again condensing all the important information in order to check that your SQL deployments in Azure VMs are following our guidelines and best practices. So what are the typical questions that people typically ask about this topic? So I divided these questions in under 3 buckets. The first one is kind of generically related to performance and to the existing characteristics that customers may have in terms of SQL Server deployments on premises, and try to understand basically how to accommodate these workloads in Azure VMs. The second part is specific on the storage subsystem. Storage subsystem is probably the biggest difference you will find between your traditional on-prem deployments and Azure. So there are a lot of details behind the scene that it's important to understand when we are going to deploy new solutions on SQL and Azure VMs. The third part is around high availability, disaster recovery, or I would say more business continuity, and are more related to what kind of options we have in order to make our deployments available in when they are running basically in a cloud environment like Azure. I do have a lot of content here, so I can go and talk for the remaining time of the session. But if you have questions, feel free to write those questions in the tool, and we will make sure that the most interesting questions will be picked up, and I will stop and answer those immediately. Or otherwise, if you have additional questions, at the end of the session there will be a formal Q&A portion of this, and we will make sure that all your questions will be answered. Okay.
Silviano, real quick,
sure.
if you want to, if you have the link to that white paper handy, if you want to throw it into the chat, we can go ahead and send it out to everyone.
Yeah, let me check. So I can definitely copy and paste this one. This is the, as I said, the kind of condensed version, and this is the full white paper.
All right.
That I just mentioned. Perfect.
All right.
Okay. So, so in terms of general performance-related questions, most of the time customers are coming with this, okay, I have a 200, 500, 700 gigabyte database on premises. Can I move it to Azure? And of course, the answer is, it depends on a number of, dimensions. We will go through, some of the technical details, but at the end of the day, the three most important, dimensions that we need to understand are about, what the size of the real, active portion of your data set, because, as we all know, SQL Server is maintaining in the buffer pool data pages that are typically, most commonly accessed by, application and user queries, and because of the differences that I just mentioned in terms of the storage subsystem that we have in Azure, it's really important that we can keep in memory as much data as possible in order to provide, the best, response time and, the best performance possible. So, understanding, what is the active data set size of my, 10 or 700 gigabyte database, it's definitely important, and selecting the right VM size depending on this is going to make a big difference performance-wise. Another important aspect is how write intensive my workload is, so how log throughput I'm going to generate, because again, this can change the way I want to configure my storage subsystem, and also is going to impact whatever high availability and disaster recovery solution I want to I'm going to choose for hosting my SQL database in Azure. Another super important aspect is around latency. Latency not only between my application tier, where my code lives, and where my data, my SQL database is deployed, because as all the other typical cloud environments, latency can be a little bit higher than the equivalent on-premise deployment topologies, because we have complex compute and networking configurations here, so we may experience a little bit higher latency in this area, but also it's important because between our SQL Server VM and the storage subsystem that in Azure is a networked equivalent, if you will, this is the latency tends to be higher. So if my application is, for example, a chatty one and is going to hit multiple times the disk, for whatever operation my stored procedure, my application is executing, this can impact my overall application response time and performance. So let me see if I can move to the next slide. Okay, so again, one important aspect around performance is what kind of VM size should I use to host my SQL Server databases. Here you can find a list of all the currently available VM sizes that we have in Azure. We suggest customers to start at least from the A3 in terms of VM size, because basically the typical amount of memory, CPU cores, and the number of maximum attached disks that you have starting from A3 VMs are the ones that we think are the most interesting one to host the production level workloads. Sure, go ahead.
Silviano, yeah, that actually plays into the first question we've got right here, which is, what would you recommend for a dev test environment on SQL on Azure VM? And so that's perfect. So you're saying start at least at A3?
Yeah, so if it's a pure dev and test, and you just are basically testing functional characteristics of your application, and you want, of course, to save some money, I would say that A1 and A2 are excellent as well. I definitely not recommend A0, because A0 has a shared core environment. So basically you are sharing a single core with other VMs running potentially on the same hardware nodes. So that's definitely not recommended for running a workload like, for example, SQL Server or Visual Studio or whatever else you are using to dev and test your application. So if it's a pure dev and test, A1 or A2 are working fine as well. If it's a production environment, I would definitely recommend starting from A3. And as you can see here from the slide deck, as you move down in this list, you are starting to reach some interesting size in terms of memory available, and also number of CPU cores. And we recently announced the next generation of computing platform for Azure. And as you can see here, the A8 and A9 VM sizes are now using Intel Xeon processors, while the other VM sizes are using AMD processors. This is important if you are looking for the most performing environment here, because Intel processors are way more efficient than AMD's in this particular configuration, and this is not going to impact only your compute requirements here, but the new processors are also way faster to process networking and storage IOs, and this means that at the end of the day you are going to achieve better IO bandwidth with these two VM sizes, even if the number, the maximum number of attached disks are exactly the same. So, we have a maximum number of external or attached disks that you can use on each VM size. As you can see, 16 is the maximum number that we have right now. Each one of these attached disks can provide up to 500 IOPS, and so while you have this limit of 16 by 500 IOPS for the top three VM sizes here, what we have experienced is that with Intel processors, the amount of actual I/O bandwidth that you can achieve is higher than the equivalent that you get with AMD-based VMs. And I have some supporting data for this particular numbers later on in my presentation. So I just ran a very quick and kind of empirical test in order to understand what's the difference between a traditional desktop-based Intel processor like the Core i7 on my notebook here, A7 AMD-based VM, and one of the new Intel-based VMs that we have. And as you can see, while what we have in our AMD-based VMs in Azure is pretty much equivalent or a little bit higher to what we have with a typical desktop-based processor, with these new Intel Xeon processors in A8 and A9 VMs, you can get something like 4 times or even more, the amount of computing power, compared to these AMD processors. So if your workload is really CPU intensive, or if you want to get the most out of your VM performance, I definitely suggest you to take a look at this these A8 and A9 VM size, because these are super interesting in terms of performance that you can achieve. So again, just to recap, for production environments, at least at A3 VMs, because these are giving you the amount of attached disks and compute and memory capacity in order to run your production workloads. A8 and A9 are definitely a big boost in terms of compute, but also in terms of I/O performance. And these A8 and A9 are also giving you a good amount of memory available, so that basically you can host your data set, all or for the most part in memory, and you are going to basically reduce the impact of the I/O latency issues that I was mentioning before. So another aspect of the performance evaluation that I was mentioning before is how to troubleshoot potential performance issues when I'm evaluating this move from on-prem to Azure. And basically, the tool set that you can use is exactly the same tool set that you are using on premises. The key performance counters, to keep in mind are pretty much the same. You can automate your troubleshooting process by using, for example, PowerShell to automate your SQL I/O testing, parsing the results and execute your tests even remotely. You can launch these tests on your starting from your local machine by using the remoting capabilities of PowerShell inside your testing VM in the cloud, and collect all the information, analyze the results, and decide basically if the VM size that you selected is the correct one, and so on and so forth. And of course, you have all the DMVs and XXX capabilities, because this is the full SQL Server running in your Azure VMs. So you have DMVs like OS wait stats, exec query stats, I/O virtual file stats that are helping you to understand where potential bottlenecks are coming from, and then you can basically decide how to if moving to a bigger VM is helping you, or maybe you want to spend some time and tune your application workload so that you can save some money and by running your workload on a smaller machine. Again, I'm not going to repeat all these well-known performance counters related to storage and all the other dimensions that we have, because every SQL Server savvy professional probably knows these already, and there's a lot of literature available on the MSDN and other websites in order to get to understand how to troubleshoot performance with SQL. But there's an important aspect that is not strictly related to SQL Server, and is instead related to the Windows Azure Storage that is hosting our disks, our data disks for Windows Azure VMs. How to troubleshoot and to monitor the performance of the underlying storage is something that you can do with Windows Azure Storage Analytics. Again, you will find on the slide deck some links that are explaining you how to use this monitoring analytics system for your Windows Azure Storage accounts. And what you can do by using the portal directly, the Windows Azure portal, or by using PowerShell or REST APIs, is to set up for the storage accounts that are hosting your data disks. The data disks for your Azure VMs, is to enable the monitoring service and make sure that basically the monitoring service is capturing all the most interesting metrics for your storage account. These metrics are giving you things like how many requests in total are hitting my storage account, how much data in ingress and egress are moving back and forth between my VM and my storage, understanding, for example, latency, so the end-to-end disk response time from a storage perspective, in this case, not from a VM perspective, like the performance counters that I was mentioning before can give you. So basically, you can compare these numbers with the ones that you are looking at in your VM and see, for example, if the storage configuration that you decided to implement, for example, may generate throttling events or errors on the storage side. And so you can basically think about rebalancing the current storage configuration in order, for example, to get the most out of your storage accounts and avoid these throttling events that can, make basically your disk response time going up just because, again, your storage may be misconfigured for whatever reason. And again, you have the ability to basically visualize those metrics directly on the Windows Azure portal, if you like, again, by enabling, the logging and monitoring capabilities, and just, by, again, plotting, the metrics that are important for you in the Azure portal, and you will see, immediately, you will start seeing, this monitoring data flowing, and you can, monitor in the long term or in the short term what's going on your on your storage accounts. And why I'm spending so much time talking about storage, because this is probably, as I said, the biggest difference that we have when we are running our database workload in Azure compared to what happened on premises. It's important to understand, as I said, that all our data disks in for our Azure virtual machines are basically VHD files stored in the Azure Storage blob facility, and Azure Storage is a shared service, is a shared storage service, is actually a general purpose storage service that is hosting whatever type of binary file. In this case, if these files are formatted as VHD files, you can attach these files as disks to your virtual machines. Essentially, behind the scene, the Azure Storage Service is going to distribute all the segments, the fragments of your VHD files across a number of physical disks. And we will take a look later on at how the storage system, the storage service is implemented. But essentially, it's not a conventional, disk, subsystem. It's not even compatible with a SAN, traditional SAN system. But it's something different, and it has its own characteristic. This is based on the scale unit that we have here is the storage account. Each storage account can scale up to 500 terabytes in terms of total capacity, and can provide overall up to 20,000 operations per second, with a total bandwidth that if it's not replicated, geo-replicated is around 20 gigabytes per second, and in ingress, and 30 gigabytes per second in egress. If it's geo-replicated instead, because storage accounts can be geo-replicated across different data centers, the amount of bandwidth that you can get is 10 gigabytes ingress and 20 gigabytes per second egress. You can get a lot of these technical details on this link that you find here in the slide. But again, it's important to understand that when we are attaching data disk to our Azure VMs, these VHD files are basically hosted by this storage subsystem, and through the hypervisor and the host partition in every host, in every VM host that we have inside our data center, these disks are basically exposed to our guest OSs, to our VMs, as normal volumes, as normal NTFS volumes that we can format, and we can use all the storage features and capabilities inside our guest OS. But behind the scene, this is a networked storage, as I said, and there's a a network connection between each and every host system that is running our VM and where the disks are actually stored. This means that performance predictability in this configuration is a little bit lower compared to, for example, a direct attached disk. But this is providing a lot of benefit behind the scene. First of all, the cost that is very low compared to an equivalent amount of storage size in a direct attached configuration. But it's important to understand the behavior of this storage subsystem so that we can configure our VM accordingly. How a single data disk in terms of performance is providing up to 500 I/O per second, but this metric 500 I/O per second is based on 8K I/O blocks, reads and writes. In fact, as you can see here, these are performance tests that I run on top of different configurations in terms of a number of disks and the striping technologies that I've used and so on. But on average, what you can get for this 8K I/O blocks is up to 500 IOPS for reads and writes, and around up to 4 megabyte for this I/O block size, megabyte per second. But as you can see, for example, when we are increasing the size of the I/O blocks, the amount of IOPS that we can get is not exactly linear. In fact, for example, in this case, while we are getting the full 500 IOPS for read operations, in terms of write operations, we can see that we can go up to 300, around 300. These are not precise numbers. These are average numbers that I calculated across a number of SQL I/O tests that I run on Windows Azure VMs. And again, when you are increasing again your I/O block size, you can see that you can get up to 300 IOPS for both read and writes and around 60 to 70 megabyte per second. So these are the performance of a single data disk. So when you're, for example, attaching this single data disk and you are moving your database files and data and log files there, this is what you can get from a single disk. If you need more than this, then you need to attach multiple disks, and essentially you can adopt one of the disk striping technologies that we have available in Windows Server in order to expose a single volume or a number of volumes that are based on the multiple of these data disks attached to our Azure VMs. So we suggest to leverage Windows Server 2012 storage spaces in terms of disk striping technologies, because we have found that this is the most efficient and also probably the simplest way in terms of again striping multiple data disks. There are some important notes here. When one of the parameters that you can define when you are creating your storage spaces is the number of columns. Number of columns basically it means the number of underlying disks that Windows Server storage spaces will use to load balance your I/O operation. And this is really important. That is, whenever you are creating your storage space, you are using for the number of columns parameter the maximum number of data disks that you are using to create the disk pool supporting this storage space. So if you attach 16 data disks and you create a storage pool on top of these 16 data disks, the number of columns that you have to use when you are creating your storage space must be 16 in order to get the maximum IOPS and bandwidth. And another important parameter when you are creating your storage space is the interleave. Basically is the stripe size. For OLTP classic workload, we suggest you to use the 64K stripe size, while for the typical data warehousing or scanning type of workloads, we have found that moving to 256 kilobyte is providing you the best results in terms of I/O performance here. So essentially, if I need more than 500 IOPS per second and more than 60 or 70 megabytes per second, I need to attach multiple disks, and I basically have two options: create a single volume, single virtual disk built on top of all the disks, the available data disks that I have, and place all my data and log files there for both my user and system databases. This is definitely the simplest configuration that I can have, and this also means that all my databases will share the amount of IOPS and bandwidth that all these available data disks can provide. The second option that may be a little bit more complex to implement, but it can give you, for example, the ability to create multiple pools with a kind of a variable number of disks assigned to these pools, and to place your data and log files accordingly based on the amount of I/O workload that you may need. You may have an existing on-premise system where you are measuring the amount of IOPS and bandwidth that you are using for logs and data files. So you may want, for example, to create 3 different pools. One pool may have 8 data disks attached, and you want to place your user data files there, for example. You may have another pool that is 4 data disks for your log files, and you may reserve 4 data disks for hosting your TempDB data and log files. And in this way, you can carefully craft how many IOPS and bandwidth each of these 3 different type of workloads will receive. Again, these 2 options are totally fine. There's also a third option that I haven't mentioned here, that is basically use these data disks as individual volumes and leverage SQL Server striping capabilities. So basically the ability to create a number of data files in your database and place these data files on each individual volume. And in this case, the SQL engine will do the balancing between all these data files that you just selected. In my opinion, this is a more complex layout, and at the end of the day, doesn't provide you a lot of benefits, especially for log files, where if you have a single volume based on a single data disk, the best you can get is this 500 IOPS and 60 megabyte per second. But if you need more, without using striping technology like storage spaces, you will never be able to get more than these 500 IOPS. So I definitely suggest you to leverage storage spaces, because this is a really, really interesting technology, and in terms of performance is actually the best we've been able to achieve. So if you are interested in some numbers, I'll leave you this. Go ahead, Aaron.
Silviano, yeah, I just wanted to remind people, if you have any questions, you can feel free to jump in and start sending us questions. That's all.
Perfect.
Thank you.
Yeah, and I did some measurements around different disk configurations, aggregated this performance using storage spaces. As you can see, I've used 4 disks volumes, 8 disk volumes, and 16 disk volumes. And as you can see here, for the 8K pages that I mentioned before, the behavior is pretty linear. In fact, with 4 disks, you get 2,000 reads and writes. For 16 disks, you get 8,000, and the behavior is pretty linear. But you can see that when your I/O block size is increasing, the behavior is not exactly that linear. And what we have seen is that this is typically due to the fact that because this is a networked I/O subsystem, as I said, the ability from your VMs to process IOs and bandwidth basically tends to decrease with larger IO blocks. I did this test on A7 on a A7 VM. I repeated the same set of tests for a A9 VM, and as you can see here, the numbers in terms of larger I/O blocks are way better than the A7 VMs. So this essentially means that with faster processors like the A9 and A8 can provide, you are not only getting more compute power, but you are also improving the ability for your VMs to consume I/O results. And this means that basically if you definitely need I/O performance in your SQL deployments, A8 and A9 can provide you this additional boost in terms of performance. So this is definitely another suggestion that we can give you. There's another option to host a SQL Server data and log file. This is known as XI or storage integration. So basically, you can create your database and specify in your create database statement that your data file or log file is sitting not in your C or D or E volume, but is sitting directly on Azure Blob Storage as a pure blob. So this is not using the VHD formatted disk that I was mentioning before. This is just placing data file and log files as blobs in the Azure Storage subsystem. What we have found is that this is not providing any significant benefit in terms of performance, but can be helpful in specific migration scenarios where you have to attach, for example, a high number of files, or you want to basically move from on-premises to the cloud using Azure Storage as a kind of an intermediate storage system between these two environments. Our recommendations are to use data disks wherever possible, to move all the user and system database files to data disks. Don't leave, for example, tempdb on the operating system disk because the performance are not optimal. So move everything to data disks. Turn off the data disk cache. That is basically an option that is there for specific scenarios, like, for example, to reduce latency for the operating system file access, but is not definitely useful in a database system scenario. So just leave the default turned off in terms of this cache for attached disks. Just create your storage pools and place your data log and tempdb files there. Depending on your needs, you can create multiple storage pools or just one single storage pool and place all your data files there. In terms of data contention, this you can use the good old guidance that we have for creating multiple, for example, multiple tempdb data files and avoid contention, or even in your user database, data files, you can create as many files as you think are great, and follow the best practices in order to monitor contention and so on, because nothing changes in that sense. Wherever possible, just leverage data compression, because this is going to reduce dramatically your I/O requirements. And as we have seen, I/O can be the most challenging layer of your solution when you're moving to a cloud-based environment. Also leverage instant file initialization, because again you can gain a lot of time when you're creating new files, adding new files, or for example you're changing the size of your data in log files by leveraging instant file initialization. So Again, nothing new. These are all good old best practices, but are even more important when you are moving these to Azure. So I'm just pausing for a second and asking Aaron if some questions have been asked in the Q&A session.
We don't have any questions right now, but I was kind of curious on the PowerShell that you were mentioning earlier. Do you have any examples of how you would go about doing that?
Yeah, definitely. So the white paper that I mentioned, let me go back to that one, SQL. In the white paper, you will find let me open this doc. In the appendix, here we go. You will find all the kind of step-by-step guide on how to add Azure Data Disks, how to, for example, create a new storage pool by using a number of underlying data disks, how to create the new virtual disk, and so on and so forth. So I definitely recommend you to take a look at the white paper. And again, we're going to refresh this white paper by the end of this month, so you will see a number of other options and refresh information here. You also will find in the white paper how to run your own performance testing by leveraging, for example, SQL I/O. We pre-configured a number of SQL I/O tests for you so that you can understand, better understand the behavior of the Azure Storage subsystem, depending on the different I/O block size, disk queue conditions, and so on and so forth. Okay, so I will use
the link to that.
Sorry,
if you want to put the link to that in the chat, I'll be happy to share it out to everyone.
It's one of the two links that I already shared, actually.
Okay, great.
Yeah.
The first one, perfect. All right, I already shared that.
Okay, so let's talk a little bit about the kind of business continuity and disaster recovery options that we have. Backup and restore. How can I back up and restore my database once these are in the cloud? Or how can I, for example, deploy new or existing databases from on-prem to the cloud? So we added a number of features in SQL Server Management Studio, like, for example, the deploy wizard that is actually starting from an existing database on-prem and is guiding you through basically the number of steps that are required to deploy this database in an existing Windows Azure VM, or also deploying a brand new Windows Azure VM with SQL already installed, and deploy your database there. This is a really helpful approach that you can use in order to move your existing database from on-prem to the cloud. Of course, the amount of time that it will take, it depends a lot on your existing VM size. I recommend to use this kind of automatic approach for database sizes that are not super big. So 10, 20, 50 gigabyte, it works. But if you have a half a terabyte database, you can probably pick up a more precise way in order to move your data files to Azure Storage, and then from there to attach the data files to your SQL Server instance running on Azure VM. In general, in order to you can back up and restore your databases from an on-premises instance or from a SQL instance running in Azure VMs directly to and from the Azure Storage accounts that you are using. This is an example when you are backing up your database, you now have the option to select a URL as a target and to first create the necessary credentials in order to access your Azure storage account, and then you can execute your backup and restore directly from there. And this can be definitely a good option, for example, to move a larger database existing on premises, backup that database to your Azure Storage account, and then restore your database in a Azure VM from the backup that you just stored in your Azure Storage account. That's definitely a smart option in order to move data back and forth between on-prem and the cloud. Or you can execute your backup on-premise, copy your backups to Microsoft Azure Storage by using one of the tools that we have available. AZ Copy is one of the Azure Storage tools that we have, really interesting in terms of performance, multi-threaded and so on. And again, you can download your backup from the Azure Storage to your VM and then attach, basically restore the database from there. So you have a number of options and possibilities to in order to move data back and forth. And of course, you can do that through SMO if you are a developer, or you can use a PowerShell in order to execute exactly the same operation. Again, there are a number of other options. Of course, SSMS is providing a graphical UI in order to execute this, and it's a simplified way to create your Azure credential and to trigger a backup from your Azure VM or from your on-premises VM to Azure Storage. There's also an interesting tool that is helping you with previous versions of SQL Server, like 2005, 2008, 2008 or 2, in order to manage basically your backup process from your existing previous version of SQL, previous instance of SQL, and execute the backup locally for you, and then copy the backup to Azure Storage. Also, adding encryption so that you can secure your backups and store the backup to the cloud. So this tool is available. You can download it from the download center, Microsoft.com, and you can use it on your existing on-premises server, or from your Azure VM if you are using a version of SQL Server that is not supporting directly all these capabilities natively in SSMS. There's also a new feature called Manage Backup to Microsoft Azure. This is basically an agent that is available for, if I remember correctly, for 2014 only, that is basically providing you a smart way to automate your SQL backups. So basically you can trigger, you can define a number of parameters here, like the database name, the retention days, your credential, and your encryption settings, and basically the agent is taking care for you in order to create your backups, your correct backup sequence, with full backup, full database backup, your differential backups or your log backups, and you don't need to basically worry about having the last well-known status of your database backed up in Azure Storage. So this is basically putting some intelligence in automating the backup cycle and basically free you from worrying about your backup strategy for an existing SQL Server instance. And again, this can be run on-prem or in the cloud. Just a few words on the availability and disaster recovery option before the end of the hour. there are three main scenarios that we are considering actually for creating highly available deployments of SQL Server instances. Basically, you can implement a HA deployment within a single Azure region. This means basically you are creating your always-on cluster on a single region, single data center, or co-located data centers. And you are basically protecting your SQL Server databases from potential availability issues that can impact a single Azure VM. It's important to remind you that single Azure VMs doesn't provide any availability SLA. You need at least to have two Azure VM instances in order to be able to get the 99.9% availability SLA that we are guaranteed. For an application like SQL Server, in order to make sure that data are transactionally consistent between these different these two instances and so on, you need an high availability mechanism in place. Always on is what we recommend in order to create this highly available deployment of SQL Server in Azure VMs. And this means that inside the same region, so the same co-located data center, you can create your always-on availability group, and you can leverage things like, for example, transparent failover handling, and by leveraging the listener, and you will make sure that your application or user queries will hit your primary or your secondary, depending on how you have configured your availability group.
So Piano, we've got a question here.
Sure.
I can jump in. The question is, when I back up to the cloud, depending on what tier, basic, standard, or premium, will the retention period also change?
We are talking about two slightly different things here. Here I'm referring to SQL Server, to a traditional SQL Server instance installed in a Windows Azure VM, and in this case, the backup capabilities are the ones that SQL Server is providing. I think the attendee was referring to Azure SQL Database, that is the managed service, the relational managed service that we are providing. That is slightly different in terms of management capabilities and so on. But the attendee is correct. For the Azure SQL Database service, we have three different service tiers: the basic, standard, and premium. And these three different service tiers provide different characteristics in terms of backup and restore, automatic backup and restore capabilities. And yes, basic is currently the basic tier for Azure SQL DB right now is providing up to 7 days of data retention. The standard tier is providing up to 14 days of backup retention, and the premium up to 35 days. So basically, you can restore a copy of your database. Basically execute a point-in-time restore up to 7 days for basic, 14 days for standard, and 35 days for premium. But that's a different service, compared to the one that I'm talking about here. Okay.
Yep. All right. So, well, that's all the questions we're going to have time for today. Silviano, I just want to thank you for a great presentation. I certainly learned a lot, and we'll definitely play with the SQL Server and an Azure VM when I get a chance.
Great, and see you all at the PASS Summit later this year.
Yep. Look forward to meeting you there.
Bye.